This is Software Engineering Radio, the podcast for professional developers, on the web at se-radio.net. SE Radio brings you relevant and detailed discussions of software engineering topics at least once a month. SE Radio is brought to you by IEEE Software Magazine, online at computer.org/software.
This is Robert for Software Engineering Radio. I am at the Lucene Revolution Conference 2012 in Boston with Grant Ingersoll. Grant is the Chief Scientist of Lucid Imagination, a committer on the Solr and Lucene projects, and the founder of the Apache Mahout project. Grant is also the author of the book Taming Text. Grant, welcome to Software Engineering Radio.
Thanks, Robert. I'm glad to be here.
Grant and I will be talking about search and the Solr search engine. Grant, let's start out. What is search?
Well, that's a good question. So, generally speaking, search is something you want to do when you're looking for some piece of information. So typically, the way I think about search and the way most people who are using tools like Lucene and Solr, et cetera, are thinking about search is how can they put in a query using keywords and or natural language, and then get back relevant content, whether that's documents or images or whatever, such that it helps them better answer the questions that they're asking.
Solr is a search engine that applications can use. Now, why would an application want to implement its own search?
Yeah, that's a great question. I mean, there's I think a number of reasons. First off, what many people have done in the past around search is they just use SQL queries, and they do, if you're familiar with SQL-like queries, they'll do like and then star, and then the word that they're searching for followed by another star, so that they're essentially doing some wildcard queries. What typically happens in those situations is the results of the search are not very good. They're not very relevant for what a user is doing. So then they look for better ways to help users find content because, I think what we've seen in a lot of applications these days is they're very data-driven, and as soon as you have a lot of data in your application, you need some way of searching through that. So whether it's a website or your social media feeds or all of the content on your desktop or across your enterprise, you need some way of looking through that content. And so a search engine will help you do those things. And then what many people find is if they just go out and try to do that through a database or just plug in some appliance, they often find that the results aren't as good as they had hoped. And so by bringing that capability in-house through a tool like Lucene or Solr, you can often get much higher quality of results, and you can also have, of course, much more control over how and when you do searches and all of the related things that go along with search.
You've mentioned comparisons to databases a couple of times. Is a search server like a database, or how is it different?
Yeah, I think it's, there's a lot of overlap, on the one hand. I mean, of course, a database is, primarily geared towards doing relational type things. I mean, that's, traditional databases, MySQL, Oracle, et cetera. You're doing set logic, et cetera, right? Whereas with a search engine, you actually have a bit of different data structures underneath the hood that are more geared for a fuzzy matching. They're geared for bringing back, say, the top 10 results or the top 20 results, or however many results, as opposed to with like a database where it's really geared about, giving you back all of the results. Naturally, of course, you can page through them in a database, but in a search engine, it's much more about what's relevant, what the engine scores and thinks is important, as opposed to just, doing the set logic and defining which things are in the set and which are not.
How would you compare the type of data records or data model of a search engine to a database?
Yeah, it's actually one of the really powerful things that people are using search engines more and more for is a search engine is pretty flexible when it comes to that. You often hear the word schemaless kicked around when it comes to search engines. I'm not particularly a big fan of that name, but the idea here is that a given document need not conform to some strict columnar format that like a database does, right? So I can have one document can have 3 fields on them, and another document could have 100 fields on them, where essentially a field here is the equivalent of a column in a database, right? And so you often have very flexible capabilities when it comes to dealing with documents. Of course, there's trade-offs there too. You can't always do all of the things that you do with a database, but you can do most of them in most cases. And so, you can have integers, primitives, floats, etc. Often, and then you can also, of course, have text in all search engines. So, pretty flexible when it comes to how you want to model your content.
In databases or relational databases, we're used to dividing things up to tables and normalizing them. Does any concept like that exist in a search engine?
That's an interesting question. I think, to some extent, most people who go and build out search engines, they do some upfront work to get their documents into a reasonably normal form. That doesn't mean that, that you necessarily do things like, foreign keys and primary keys and all of that stuff. But it does typically mean that you have some structure that you're overlaying on these documents in terms of the fields. So, if you think about like a web page, right? Well, it's got a title, it's got a body, it perhaps has some meta tags like keywords, etc. So oftentimes you'll model your search documents that way, by defining what are the pieces of this document that you want to be able to search against.
So the Solr search engine is a value-added layer on top of Lucene. Could you break it down into what is Lucene and what does Solr add to the picture?
Sure. So Lucene is a core set of Java libraries that is designed to handle many of the core things that one needs when building out a search engine. So being able to convert strings into an indexed format, and then being able to query it. So it defines a number of different ways of querying the index. It also defines a number of different ways for getting content into the index. But at its heart, Lucene is just a set of libraries that one would have to then go and integrate into your broader application. The nice thing about that is, of course, Lucene can run on everything from a mobile device all the way up to, very, very large scales like Twitter, etc. So you can kind of build, you can take what you need out of Lucene and build around and on top of it to build out your search engine. What most people end up doing when they build on top of Lucene is to build something that looks like Solr, which is essentially a Restful service that allows you to talk to Lucene over HTTP or over a REST-like interface, right? So then you can just, no matter what your client is, whether it's PHP or Java or Ruby or whatever, you can just talk to Solr over HTTP and do your querying, do your indexing, etc. Solr also adds a number of other things that aren't in core Lucene. So it adds things like faceting, which some people think of as either parametric search or guided navigation. It also adds in support for scaling vertically and scaling horizontally, so you can add servers that can handle more and more loads, as well as handle larger and larger indexes.
You mentioned faceting and scaling. I would like to come back to those. Next, I'd like to ask you, what are the major resources available in the Restful API of Solr?
In terms of like the kinds of things that you can ask of Solr?
Yeah, or what can you, I assume there's something you can create objects and then you can get objects. So what are the...
Sure. So Solr is REST-like. I wouldn't say it's necessarily a pure REST API, but it's fairly similar, and people who are used to programming REST won't have a problem with Solr. But so on the indexing side, you of course can push documents into it. So essentially you're adding or creating documents in the index, as well as you can update documents in the index and delete them. You can do that in a variety of different ways. You can push in XML. Solr defines like an XML format you can use. You can also use JSON. You can also push in even, what we call rich documents, things like PDFs and Microsoft Office. You can push in CSV files as well. So there's a wide variety of ways of getting content in. And then you can delete in a variety of ways too. You can delete by an ID. You can delete by a query. So you could actually specify, hey, I want you to delete all the documents that match this particular query. So that's pretty expressive there on the indexing side. And then on the query side or the get side, if you like, quite a number of features there. In fact, both Lucene, from Lucene and then up into Solr, we provide a number of different query parsers that allow users to express their queries in a variety of different ways. So you typically have users will say, I want to find the word IEEE in the title field, and I want to find search in the body field. And so you can express queries like that. And you can get quite complex. So you can do basic keywords, you can do phrases, you can do what are called fuzzy queries. So like if you want to find based on perhaps introducing wildcards into your queries, and a number of different things. At that time, you can also ask for things like facets. You can ask for spell checking. So you've often, I'm sure, seen on Google where if you misspell something, Google will say, did you mean? You can do that right out of the box with Solr as well. You can ask for Solr to take all of the results that it finds for a query and to highlight them. So in other words, find within the document where the actual match occurred, such that you could then display that back up and out to your users. And then, there's a whole variety of other things I'm just barely scratching the surface on.
What I understand from your last comment is you can do more of a SQL-like expression where you're doing exact matches on some terms, mix that in with a search type of operation, or you're doing a text search on other terms. Is that correct?
Yeah, so you can, with essentially this fielded syntax, you can do exact matches within fields, you can do fuzzy matches within fields, you can look for phrases, you can look for terms near each other. You can also do some basic join capabilities so that you can join two documents, which is often what happens in a database. But I won't go in so far as to claim it's a full join capability like one gets with SQL. So I don't know if the SQL comparison is totally accurate, but I guess at the end of the day there are a number of different ways that allow you to go in and dig into your index and ask these kinds of questions of it that you're perhaps used to doing in SQL as well.
You mentioned faceting a couple of times. Please tell us, what is faceting?
So faceting is essentially a way of narrowing down your search results with known values. So probably the best way is just to give an example. If you've been on most major e-commerce sites these days, like Amazon or I don't know, Target.com or Walmart.com or any of the other ones, they will have, when you do a search, you will then often see on the left-hand side what are called facets. And those things will help you narrow down your search results. So for instance, if you type in the word TVs, on the left-hand side, you'll often see, it broken down by price, by manufacturer, by rating, et cetera. And those are essentially what we call facets. Some other search engines call them guided navigators, or databases often call it parametric search. So those are a number of synonyms for faceting. But the nice thing about facets is when a user clicks on them, it's going to filter down the results, but they're guaranteed to know that they're guaranteed to get back those results, right? So if the facet says there's 5 Sony TVs, when they click that, up will come 5 Sony TVs as the results. And so it's a way for users to narrow down searches, especially when they're not quite sure how to put in their query and what query terms to put in to find what they're looking for.
Would it be fair to say that Faceting enables the application designer to implement a kind of a browsing type experience with a drill down?
Exactly. And in fact, we have at my company, we have a number of customers who, their application doesn't even have a search box on it, but their entire site or application is driven by search, and they're doing exactly what you're talking about there. They're using queries plus facets underneath the hood, and all depending on what the user clicks on will then change the navigation within the site. And so it's very useful for making highly dynamic websites.
I think that is a great answer to my earlier question, why would application architects want to implement their own search capability?
Yeah, no, that's true. We see that a number of times. Of course, many of them also have search boxes too. So, but it's been interesting for me that I started out just doing pure text-based search, and you see over time you see so many people doing things that are go well beyond just pure text search, and are things like driving their whole website off of the search engine.
Yeah, it becomes a kind of ubiquitous part of the experience rather than a separate feature.
It really is, and that's why I think Lucene and Solr are so powerful for so many people. Is everybody just kind of needs to have search in their application these days. It's almost taken for granted. Whereas 5-6 years ago, it was maybe a bit more challenging to convince people that they needed search in their application. Whereas now, I don't ever have to explain that to people.
Change tracks a bit here. You've mentioned the index several times. Tell us, what is an index?
Sure. I think the easiest ways is to just think about the index in the back of the book, right? In the back of a book, right? You have a list of words and what pages they occur on, and then so as a reader, I can go back there and I say, oh, this word occurs on page 500. I'll go look up that word right on that page and see the context. Underneath the hood in Lucene, that's essentially what's going on. We keep a dictionary of all the words that we've seen, and then we keep track of what documents they've occurred in, and then you can optionally also keep track of where within the document they occurred. And so then when a query happens, what happens is the query comes in, you go look up in that dictionary what that term is, and then what page, essentially what documents it occur on, and then you can go off and score those documents. So it makes for a very efficient retrieval of matching documents and then being able to score those. And of course, in most modern search engines, there's all kinds of tricks you would do to compress that dictionary, to compress the storage of what documents it occurs in, et cetera. And, Lucene's no different there. And so you can often see, like if you have, say, a gigabyte of raw content that you want to index, the index itself, is often significantly smaller than the original raw content. I've seen it in some cases it's as low as 15% of the original.
Is the image persisted?
It can be. We actually have options for it to just be in memory or to store on disk. Most people in most situations store on disk and then just load that up when they start up their system or do their indexing or whatever. But I've seen applications that are essentially transient. They only index what's coming through, and it's only available while the process is running, and they don't save it.
Is the image of the index typically larger than what could fit in the memory on the server? Well,
that's of course changed over the years, given how much memory one can get in a server these days. But in many cases it is, and in many cases it's not. It really is going to depend on the amount of content that you have, and and the kinds of things that you're asking the search engine to do. I've seen plenty of applications. If you have 16, 32, 48, 96 gigs of RAM, your index, of maybe even, 10, 20, 30 million documents or more can often fit all the way in RAM. So, it really depends on what your goals are for performance, et cetera, as to how you would want to do that. But most people in most situations just use a file system-backed index, and then Lucene does a very good job of loading into memory the things that it needs in order to be fast.
When a client application pushes a document into Solr, can you walk us through the steps that take place to get that document indexed?
Sure. So, assuming it's one of the more simpler forms and not like an Office document like I mentioned earlier, so say it's JSON or CSV or XML, so essentially that kind of document, it looks like it has a bunch of fields, which are the keys, and then the value is the actual text that you want to index. And, so Solr comes in, does some, fairly lightweight pre-processing, and then essentially hands it off to Lucene. Lucene then goes and takes the individual fields and their content, and then depending on how you have it configured, it will essentially try to convert that content into the dictionary that we use for inside the index, right? So typically that process is called analysis. And what we're doing there is taking and tokenizing the terms in the string and then using those tokens as the entries into the dictionary. And then, of course, as you've seen tokens, then you can keep track of, whether you've seen it before or not, and then go and add the necessary document IDs into the index list, right? So that's a pretty basic description of it. We obviously do a lot of things to make that fast and make that efficient, and to be able to still serve queries while we're doing those things. But in a nutshell, that's, you ingest the document, you tokenize and analyze the document. The tokens that you get out, you shove into this inverted index format that I described earlier.
Okay, so you're updating this index and you're also serving queries. Databases, or transactional databases, is a very strict consistency model for how updates and read operations are interleaved. What sort of consistency model does Solr and Lucene provide?
So you can do, I think actually we would say now that we're fully ACID compliant, you can do, essentially a prepare and a commit if you want. Most people don't need that kind of transactionality, and so what you have in many situations is what we would call an eventually consistent model, whereby, documents go into the index in one hand, and then at some period the searches refresh its view of the index. Essentially, you have this snapshot in time of the index for serving up queries, and then in your application you can decide how often you want to refresh that snapshot. Now, having said that, in the newest release that's coming out in Lucene and Solr, you can change all of that such that you can pretty much after every document you can open up a new version of the index and do queries against it, so that you can see every document as it comes in. So that's what we call near real-time searching. That's changed pretty significantly in probably the last year to be a lot higher performing than it was in the past. But yeah, I wouldn't say, one of the things I think a search engine typically trades off is it's not a fully transactional system like a database. And that's often fine for the kinds of applications that people most use a search engine for.
Sure. Well, in many applications, the updates are coming from within the system itself or from the business, and the reads are all done by the customers. So if somebody's adding, say, a new camera into their inventory, they really don't care if the customer sees that camera now or in 10 seconds.
Exactly, and that's exactly why it's often designed that way. Like I said, it is now possible that you can pretty much see every document as it comes in, and so even that case is handled much better now. But yeah, you're exactly right. I mean, if you're indexing Twitter, you don't know whether some new tweet came in 1 second ago or 5 seconds ago. So as far as I have to ask the system again for the results in order to see the updates.
Another question about index is if you index based on the words in the document and you have queries with 2 or 3 words or a phrase, how does the index find that?
So in the index, you can keep track of the positions where words occur, and so then essentially it becomes a simple math problem of determining what the distance is between 2 words based on their positions. You can also do much more complex position type things of saying, this phrase near that phrase, or these words within the first 5 positions of the start of the document. So that you can get some fairly complex types of queries that way.
Does Lucene understand any data types besides text, like maybe date or integer?
So it does have some support for numerics, which of course you can map dates into numerics, and then but you can overlay those kinds of semantics onto it. Solr does have a much deeper understanding of primitives, right? So it supports things like ints and floats and doubles, and as well as just strings. And then we kind of call strings in text. So a string would be just the literal, and you have to do an exact match on it. Whereas text, we would say, gets tokenized and split up into its component words. But at the end of the day, all of this just ends up being a pretty straightforward string match underneath the hood in Lucene, whether it's a number or whatever. So, Lucene itself doesn't have to care, but you can tell it to care if you want it to, if that makes sense.
I think that sounds like one of the major differences with the record-oriented databases is it's really optimized around text, whereas record-oriented, you're doing a lot more strict data typing.
Yeah, so I would say, Solr, that's especially the case with Lucene, although, like I said, we do have more support for numerics now. Solr, I think, has always had this overlaying of type on top of it, and so if you want Solr to be strict about types, you can, but if you don't care about it, then you don't have to. And so I think it gives you a lot of flexibility that way. It's been interesting, like I said earlier, watching all of this evolve, because I think, search engines in general have been taking on more database-like qualities, whereas I think databases perhaps have struggled a bit more with taking on search qualities. And so, I think in Solr especially, you can do a lot more things that you're used to doing in a database, like, applying functions on top of numeric. So you can take the sum and multiply it by things. So if you have a field that's a numeric type, you can add to it, you can subtract from it, you can sum it with other fields, all of those kinds of things. So, that gets to be pretty powerful for people who are building out these kinds of data-driven applications. And like I said earlier, too, we've even added some join capabilities as well. I think probably one of the big things that's missing so far is a general purpose aggregations or grouping, but even that we do have some capabilities there, and I think in the pretty near future you'll see a lot more when it comes to those kinds of things where you want to say, give me the sum of the values of this field across all of the documents that match a query, right, which can be pretty powerful.
If I'm designing an application, I ask you, Grant, here's what it does. Do I need a database? Do I need a search engine? Do I need both? What's the division of labor between them? Do you have some general guidelines for how you make that recommendation?
Yeah, I mean, I try not to be too biased when it comes to these things. Obviously, I've been working on a search a long time, and think search engines are great for a lot of things. But as an application developer, as a programmer, it's your job to make the appropriate choice of tools given the situation you're in. So for databases, the things that it's good at, transactions, relational math, etc. That's the best place to do in a database, right? If you need to do joins, if you need primary key and foreign key consistency, etc., that's where databases belong. If you're dealing with a mixture of structured and I'll use the word unstructured, although I don't particularly like it, unstructured text, then the search engine often becomes much more powerful because you have this ability to do the fuzzy matching against the text part of the content, and then combine that with your application layer understanding of the structured part of it, right? So you can get and build out some pretty complex things that way. I've also seen a number of cases where, just simply put, the databases don't scale to the size that a search engine can do, especially because if you can denormalize your data a little bit, I think that often frees you up to be a lot higher performing in your system. So it really does, though, come down to what's the appropriate choice for the tool. I've seen many applications that successfully use both of them in conjunction. I've seen cases where search engines have just flat out replaced the database altogether. I can't say that I've ever seen the database fully replace the search engine now. So even when many of the database vendors have tried to add search into their system and, to some level of success, I guess, but I don't think it ever has matched, a pure search engine capability.
Once we've got the data all in the index and then the queries start coming in, how does the engine decide what are the most relevant search results out of all the ones that might match?
Yeah, that's a great question. I mean, and it's actually a pretty hard problem because what's relevant to you and what's relevant to me may be very different. If at the end of the day, a good chunk of it's going to depend on the way you're asking the query, right? So if you're telling it, you can tell Lucene and Solr, like for instance, that this term and that term must occur together somewhere in the document, or you can say things like, this term or that term, or this term and not that term. You can also do the phrases, etc. So what Lucene does is, it takes that query in, and like I said earlier, it goes and looks in the dictionary and finds the possible candidates for scoring. And then essentially we have a scoring model underneath the hood that based on probably 40 to 50 years of academic research, has been proven out to be pretty effective for scoring. Goes in and determines what that score is based on the criteria of the query. Now, one of the nice things actually that's coming in the next version of Lucene is you can actually even just plug in your own scoring model. So if you have a different way of thinking about what's relevant, you can plug that right in, and Lucene will just continue to chug away and produce results. But if for those who are more academically inclined, what we primarily use is what's called the vector space model. So if you remember your calculus or your trigonometry, et cetera, from college or high school, whichever covered it for you. If you can think of a document as being a vector in an n-dimensional space. So if essentially each word is its own cell within that vector, and then you can do the same thing for the query. And so then if you bring the tails of those two vectors together, you'll have an angle that's formed between those two. And then what typically happens in a search engine is if you take the cosine of that angle, you get a number between -1 and 1. And if you remember, again, your trigonometry, you'll know that the cosine of 0 is 1. So, and I think intuitively that makes sense that these two vectors overlap each other. And so you would say, yes, those are intuitively, that's a relevant document. Whereas if the angle is really large, the cosine is going to be, either down towards 0 or -1. So hopefully, given the audience, I think that should be hopefully a useful explanation.
So is the most relevant articles, is it the outcome of doing a sort where you're able to compare each pair of articles and say which one is more relevant? Or is there anything like what they do with Google PageRank where the position of each item in search results is a property of the entire set and how each one's interrelated to all the other articles?
So, you can overlay something like PageRank on top of this vector space model, but at its heart, the vector space model really is just at the end of the day, it comes down to things like how many terms does the query have in common with the original document, and then what are the importance of those terms, and then as well you can have other factors like what's the length of the document, how many words are in that document, because I think you would agree, all else being equal, I would a shorter document that has the query terms in it is more relevant than a longer document that has the query terms in it, just because I think we would all prefer to get the answer sooner, right?
Sure. Well, if you have a long enough document, it would have every word in it. So. Right,
or a lot of them, and it would it often has the query terms in it multiple times, right? So that's what we call the term frequency. And so one of the things that Lucene does is use the term frequency to determine how important a particular word is. It offsets that term frequency by how often that term occurs in the whole collection. So that's called the document frequency or the inverse document frequency. So you'll hear in search speak, you'll hear a lot of people say things like TF-IDF weighting or TF-IDF scoring. And so essentially at the end of the day, what Lucene is doing is given some query term, look up what its TF values are, look up what its IDF values are, and then do some math on that to determine, how important that word is. And then given all of those, given that across all of the terms in the query and in the document, you can then come up with a score, right? And so there's various ways of combining those weights.
Your best search result then is an unusual word that occurs frequently in a small document, but not very much else in the document set.
That's exactly it. That will be the most important words, and then so what will happen is those documents should rise up to the top. Now, of course, in Lucene, because it's open source and because we strive to make a lot of this pluggable, you can, of course, change those kinds of parameters if you think you have a better model. But yeah, essentially you've hit the nail on the head there.
What are Solar and Lucene implemented? What language are they implementing?
So Lucene Core, or what you can get from Apache, the main flagship is in Java. Solar is as well. The large majority of it is in Java, but we do have there are a number of libraries out there for other languages to make it easy to connect to Solar. Lucene itself has been ported to pick a language. It's been ported to Python, it's been ported to Ruby, it's been ported to Perl, it's been ported to C, it's been ported to Objective-C. I think it's been ported to even a few other variants in there that I can't keep track of. And then typically in those portings, in .NET as well, typically those portings, what they're trying to do is maintain file format consistency, but they may then go and change some of the APIs to better fit with that language's view of the world when it comes to creating APIs. But yeah, the core flagship, what you get from Apache, that's all Java.
Tell us a little bit about the history of the Solar and Lucene open source projects.
Sure. So let's see if I can remember it. It's been so long. Lucene itself is 15 or 16 years old at this point. Like I said, it builds on top of 40 to 50 years of academic research, and pretty much implements the standard way of doing search that most of, whether you're buying a proprietary engine or using some open source project, the way that they do search underneath the hood. It was started by Doug Cutting. For listeners who are familiar, Doug is also one of the co-creators of the Hadoop project, which is pretty popular right now, as well as he started the Nutch web crawling project. So Doug started Lucene as kind of a side project back in the late 90s. In fact, it was a way for him to learn Java, which, for anybody out there who is going off and learning a language, they know they don't usually start with a search engine as their first implementation. But Doug, sure enough, did that. A little bit after that, he put it up on SourceForge, and then in 2001, donated it to the Apache Software Foundation, where it's lived and grown ever since. In roughly 2004, a guy by the name of Yannick Seeley and a few other people at CNET started an internal project that was building out search as a service on top of Lucene, and that is essentially the precursor to Solr. Solr was donated to Apache in 2006, and then has essentially grown right alongside Lucene over the years. As for me, I started using Lucene in about 2004, and then became a committer on the project in 2006, and then have been using Lucene and Solr kind of ever since. I would say, I guess the last thing I would add is, Lucene and Solr power some of the largest websites and applications in the world. It, in my estimation, is the most widely used search library on the planet. Where somebody can actually embed this into their application. So I'm not comparing it with, Google or Yahoo or any of those web-based search engines. But for people who need search in their applications, Lucene and Solr are the de facto choices.
Is there an active community around those two projects?
Yeah, as you can imagine, with it being as popular it is, there's a lot of people who are contributing code. I've even lost count of the number of committers these days, i.e. the people who can actually change the code at Apache. It's somewhere north of 30 people, I think, and then the broader community is in the thousands, if not tens of thousands. I've seen, estimates of number of applications using Lucene and Solr, ranging from 5,000 plus up through hundreds of thousands. So it's one of those things. Just with many open source projects, you just never know who's even using it. But it's everyday applications like Wikipedia is powered by Lucene, Netflix is powered by Solr, Apple uses Lucene and Solr in a number of places. Twitter is powered by Lucene, and on and on and on. And so it's really quite an interesting span of applications that are powered by Lucene and Solr.
That's quite impressive. And tell us about the relationship of lucid imagination. Actually, scratch that question. I'm going to read you the question. Tell us about the company Lucid Imagination.
Yep, so Lucid Imagination is a company that was founded for the sole purpose of supporting and extending the capabilities of Lucene and Solr. So in many ways, things like what Red Hat does for Linux and their projects, or MySQL does for the MySQL database, we aim to do that for Lucene and Solr in the community. We employ a large number of the contributors to it, so we contribute a lot of code back. And then we provide a range of services and products around Lucene and Solr. So on the knowledge side of the equation, we do things like training, we do support, we do professional services / consulting. On the product side, we have a couple of different products that build on top of Solr, bring into it things like content acquisition, security, web-based administration capabilities, etc. So, really designed kind of to make it many of the things that people do when they're building out applications on top of Solr, just bring all of those into the fold into a single product so they don't have to go out and build those things themselves. But we still, of course, give you all of the capabilities of solar. We don't want to hide those from you.
For people who would like to learn more about your work, Grant, do you blog or otherwise social media where people can follow you?
Sure. Yeah. Although my blogging's been a little bit down lately because I've been on a project deadline, but I primarily blog on Lucid Imagination's blog, which is just www.lucidimagination.com/blog. On Twitter, my handle is GSINGERS or G-Singers, harking back to the old Unix 8-character username days. That stuck with me over the years. So yeah, G-Singers is my Twitter handle. And then, like I said, lucidimagination.com is where you can usually find my blog posts.
I realize there's one question I'm supposed to ask right at the beginning, so this is a note to the editor to put this in right after I introduce Grant. The question is, Grant, please tell the listeners about your background.
Sure. Yeah, I'm currently the chief scientist at Lucid Imagination as well as the co-founder. I've been a programmer since graduating college in 1996. I've done a wide variety of things over the years. I actually started my career doing Fortran, if you can believe it, doing electromagnetic simulations on highly parallel and distributed compute platforms. Then, basically after that gig, I happened onto a company that was doing search and natural language processing called TextWise, and started working on a cross-language search application. So what that meant is that you could put in your queries in English, and you could find content in Japanese or French or Spanish, and you didn't have to actually know that language, which was pretty cool. And that's really where I kind of fell in love with search and natural language processing as a career. And so I've more or less been doing that ever since, although I did have a small stint at a company doing configuration management, which also has, of course, a number of uses across these things. But primarily in the early days, like I said, doing Fortran, doing C, C++, and then these days, doing a lot of Java. I've also been lately doing a lot more around things like machine learning. I'm also one of the founders of the Mahout project, which is all about building out scalable machine learning libraries. And so that's all written primarily in Java, but designed also to run on top of tools like Hadoop. So I guess that's more or less my background. Try to keep my hands dirty writing code these days, so to keep up on those skills.
I realized I had one more technical question that I somehow missed. I know we could probably spend a whole show talking about scaling, but could you briefly talk about the scaling capabilities of Solar if either your index or your volume of searches outgrows what you can run on one node?
Sure. Yeah, so from almost day one, Solar has supported really high query volumes, what is traditionally called a replicated environment or a replication environment, or sometimes people call it master worker or master slave. The idea that you have one index that fits on a single machine, and then you just need to make copies of it, and you put all those copies behind a load balancer, and then as your requests come in, you just fan them out to the appropriate available for do. Pretty straightforward, long time in Solar. In more recent years, we've also added the ability to do distributed indexing and search, and that's the case where you have an index that essentially is too large to fit on a single machine, and so what you do is you split it up across multiple nodes. These are often called shards, and then every time a query comes in, you fan out that query to all of the shards, have each of them do the scoring, and then collate the results back up and out to the user. And then, of course, these days with the types of applications that people are building, you actually need the combination of these. You need you need to handle the high query volume as well as the large indexes. And so then what you can think of is essentially building out a system that more or less looks like a matrix, where every row is a shard, and then every column is a copy of that shard. And so you essentially have this grid pattern, right, that you can then overlay with a load balancer that can go and figure out who's available for searching and what shards need to be queried and all of those things. And all of that's built right into Solr. Can do it just out of the box, pretty straightforward to set up and run, and you typically just can add hardware as you need it. One of the things we're very actively working on in the community is to make that even easier, to make the whole management of that easier as you grow out. So, right now we've got, at Lucid and in the community, we've got customers and community members who pretty easily handle billions and billions of documents in Solr. And we're, really looking to take that to the next level, even above and beyond that, right? So scales out pretty effectively, I think, at the end of the day.
Grant Ingersoll, thank you very much for speaking to Software Engineering Radio.
Thank you.
Thanks for listening to SE Radio, an educational program brought to you by IEEE Software Magazine. For more information about the podcast, including other episodes, visit our website at se-radio.net. To support us, you can advertise SE Radio by clicking the Dig, Reddit, Delicious, or /thought buttons on the site, or by talking about us on Facebook, Twitter, or your own blog. If you have feedback specific to an episode, please use the commenting feature on the site so that other listeners can respond to your comments as well. This and all other episodes of SE Radio is licensed under the Creative Commons 2.5 license. Please see the website for details. Thanks again for your support.